In this video, we will discuss the scattering in the two frames. One frame is the laboratory frame, or we will call it a lab frame, and another is center of mass frame, or we can call it a CM frame in short word, CM frame and lab frame. So here in this we will consider the two particles. Here particle is M1 and particle is M2, and these two particles, they are two particles are structureless and non-relativistic particles. So these are two particles, they are structureless and non-relativistic. And here we will discuss the scattering. First I will discuss here in the lab frame. So this is representing the scattering in the lab frame, and here I am calling this particle is M1 and this M2 particle. In the lab frame I will consider that this is M1 is target particle. We will call it, no, not target, but it is a bombarded or incident particle, and this M2 call belongs to target, or you consider target particle. And here the term which we will use here, this V1L, this is represent the velocity of M1 particle in the laboratory frame, in lab frame. And similarly here in the lab frame we will consider that the particle is at rest. This M2 particle is at rest, and this is the specification of, you can say, these particles before the collision. And after collision what will happen, that this particle will get scattered. This M1 particle scattered, this is M1, get scattered through this angle theta1, and M2 get scattered through an angle theta2. And here the velocity is after scattering or after collision. This is the picture after collision. So after collision velocity is v1l dash, and the velocity of the target particle is v2l prime or dash. Okay, so this is the representation of the scattering in the lab frame. Similarly we have the another frame, that is the center of mass frame, and we will call it a CM frame. Okay, so in this CM frame, this is the representation before the collision, and here this is particle M1 similarly, and this is particle M2. And another thing is that here particle is moving with velocity is v1c, and this is velocity is of M2 particle is v2c, and they are in the opposite direction here. And this is before collision. And after collision what will happen, that this the particle M1 will get scattered through an angle theta, and velocity is v1 prime 1c. C denotes center of mass, and L word here is denoting the related to the lab frame. This we use the notation here. And this M2 particle get scattered through an angle of pi minus theta, and velocity is v2 prime 2c. and these are the parameters after the collision. And another parameter what we have to consider, that what are the position of particle, position of particle m1 in uh, lab frame is given by, represented with the R1L. This is, and position of particle in M1 in the CM frame we denote it with the R1C. And another is the R is the position of center of mass with respect to lab frame. So this is the notation which we use when we notation which we can use if we want to find the relation, how we connect these angles, or when we want to connect the relation between the cross sections between among these two lab, before and after, in the laboratory frame and center of mass frame. So this is all about the representation, how we can represent with the help of diagram. And another thing is that here this is the direction, so from here this makes an angle theta. So along this axis we can resolve into the two component. Here this component we can, velocity component, I can write this is V1L cos theta 1, and along this is V1L prime sin theta 1. Similarly here for the particle after scattering, M2 particle, the component is V2L prime cos theta 2, and here this is component is V2L prime sin theta 2. So this is we can resolve into the component. Similarly you can resolve here the component along x-axis and y-axis in the similar fashion here, that what are the component in these frame of references. Okay, so this is basically we have discussed that what do you mean by the, this is scattering in lab frame, and this we will call the scattering this is representing scattering in the center of mass frame. So we will use these geometrical representation in the next video, in order to, when we drive the relation in term of, because here in this our objective is to basically we are interested in detecting this particle M1. So how we can, this theta 1 is related with theta 2, or we can that how they are interrelated in the among these two frame of reference, that will be discussed in the next lecture.